Welcome back to Calc AB, everybody. So again, we're looking at the FRQs. So this is for you guys to be able to do your test corrections. So the gravel plant crushes gravel into sand. The sand falls from a spout and forms a right circular cone whose radius is always twice its height. The radius of the base is increasing at a rate of 6 inches per minute. So again, one of the things you guys want to start off is, as always, make sure you guys are underlining any information that you're already given here. So we know it's a right circular cone. So it's being poured as a right circular cone, right? And then the radius is always twice its height, meaning the radius is always 2 times h. And the radius of the base is increasing at a rate of 6 inches per minute. So we can say the dr dt equals 6 inches per minute. All right. So it says find the rate in which the circumference of the base is changing when the radius is 8 inches. Be sure to include the correct units in your answer. So again, we're given dr dt equals 6 inches, right? And then we need to find, it says the circumference. So we need to find how fast the circumference is changing. So dc dt when r is equal to 8. And then the equation we're going to be using to determine that is pretty much just the circumference equals 2 pi r. All right. So again, to find dc dt, all we have to do is pretty much just take the derivative of c equals 2 pi times r. So that's dc over dt equals 2 pi times dr dt. And then to find dc dt, we just need to do a substitution. If you guys notice, I didn't have to use r equals 8. It's pretty straightforward. So therefore, 2 pi times 6, which is our dr dt, is equal to 12 pi inches per minute. And again, leave it in terms of pi, right? It says right there. You guys don't have to multiply that out. So dc dt equals 12 pi inches per minute. And then part B, it says find the rate in which the area of the base is changing when the radius is also equal to 8 inches. Be sure to include the correct units in your answer. So in this one, again, here, the given is dr dt again, which is still 6. We need to find dA dt when r is equal to 8. And then the equation we're going to be using is just the equation of the area of a circle, which is area is equal to pi r squared. All right. So we take the derivative of that. Take the derivative of, so dA over dt equals pi times 2r times dr dt. All right. And continue over here. So dA over dt. We do the substitution, and therefore we have 2 pi, right, times r, which is 8 in this case, times dr dt, which is 6. So that's 2 times 8 times 6 gives us a total of 96 pi. And in this case, it's area, so we're looking at square inches per minute. All right. And then for part C, it says find the rate at which the volume of the sand cone is changing when the height is 5 feet. Be sure to include the correct units in your answer. All right. So if you notice, we've been using inches here. So we want to make sure that these 5 feet is equal to 60 inches. All right. You'll see where this comes in handy right now. Now, in this problem, again, the volume is equal to 1/3 pi r squared times the height. All right. So that's the equation we have. Now, the given, we have to remember that in the beginning, they told us that r equals 2h. So that's something that's going to be really useful for us right now because we can eliminate a variable with that. Right. So we need to find pretty much dv dt. And we also need to find dh dt because we have dr dt, but we don't know what dh dt is. And the equations we're going to be using to be doing that, the first equation is going to be the one that, again, r equals 2h. Right? If I take the derivative of both sides here, I get dr dt equals 2 times dh dt. And then here, I know dr dt is 6. Divide both sides by 2, and you get dh dt is equal to positive 3 inches per minute. All right. It's also a rate. So again, positive 3 inches per minute. And In this case, the other equation, right, we're going to be using this one right here. So let's do dv dt. And now, before that, I actually want to substitute, my bad. Before that, I want to substitute this r equals 2h. So v equals 1/3 pi. And instead of r, I'm going to be using 2h times h squared. All right, and then you simplify that a little bit more. So that's going to be 4 pi over 3 times h cubed, and that's our v. So the volume equals, so if you take the derivative, dv dt equals to 4 pi over 3 is a constant. 4 pi over 3 are constants. The derivative of h cubed is going to be just times 3h squared times dh dt. And again, this 3 goes away with that, and you guys are just left with 4 pi times the height squared times dh dt. Now we start doing our substitution, and remember, they told us the height is equal to 5 feet, but this is feet, not inches, right? So that's why it's important to convert it back into inches, because our units are inches, right? It says right there, correct units. So 4 pi times 60 squared times dh dt, which is just positive 3. So that's going to give us a total of 43,200 cubic inches per minute. All right. And then part D says a suction device takes the sand away and puts it onto train cars. The device starts when the height of the sand cone is 5 feet. The rate at which the sand is suctioned off the cone is given by S of t equals 4,800 pi times the cubic root of t squared inches cubed over minutes. Assuming the rate of change of the amount of the sand falling onto the pile remains constant after the cone is 5 feet high, find the time in minutes since the suction device started when the overall volume of the sand is not changing. So when the overall volume of the sand is not changing is when dv over dt is equal to 0, right? That represents no change. When something is equal to 0, that represents is not changing in any direction. So that's one of the things that we have to realize, right? When does dvt equal to 0? So here, if it's going to be, the volume is not going to be changing. So we know that from the previous problem, right? We know that dv dt, is 4 pi. So this is going to be 4 pi. So our setup is going to be like this. dv dt equals 4 pi times the height squared times dh dt. And then the suction device that's taking away stuff is 4,800 pi times t raised to the 2/3, right? So just rewrite this as in pretty much as an exponent. And then again, that has to be equal to 0. So we know that this side completely, we just found it right now in the previous problem, right? It's 43,200 cubic inches. So I can just substitute that pi. Yeah, I missed the pi over here on top, my bad. Pi, and then we want to solve for t here. So again, you can add 4,800 pi times t squared to both sides. So it's going to be equal to 4,800 pi times t to the 2/3. Divide both sides by 4,800 pi. You end up with t equals t to the 2/3 equals positive 9. So therefore t equals 27 minutes. So at the 27th minutes, nothing is changing. All right, it's pretty much staying the same. Okay, now let's look at next problem. Problem 2 says the graph below shows the velocity BA of t of a particle A moving along the x-axis and can be defined a continuous linear piecewise function over the interval between t between 0 and 9. So over which time interval does a particle move to the right? Justify your answer. So again, you're looking at the graph of v sub A of t, right? So it's moving to the right whenever this is positive. So therefore I can say between 0, comma 1, right? Because it crosses the x-axis right there, between 5 and 7. And that's about it, right? So we can say that the particle A is moving to the right. It's moving to the right at 0, comma 1, right? And 5, comma 7, because v sub a of t equals, I'm sorry, not equals, but is greater than 0. All right. And then over which time intervals is particle A slowing down? So remember, when we want to figure out things that are slowing down, that's when so v is greater than 0 and the acceleration is less than 0, or when v is less than 0 and then the acceleration is greater than 0. So they have to have opposite signs. So here between 0 and 2, if you guys notice, between 0 and 2, acceleration is negative. So I can say a of t is less than 0. Here it's equal to 0. And between 3 and 6 is greater than 0, right? Greater than 0. And then between 6 and 8 is less than 0. So a of t is less than 0. And then here again, it's equal to 0. So let's look at that. Pretty much it says over which time interval is slowing down. So here it's negative between 0 and 1. We can say it's slowing down between, so particle A is slowing down on 0, 1 because b of t is greater than 0 and a of t is less than 0. Okay, and then for the other interval, if you guys notice here on the graph, it's slowing down between 3 and 5, right? Between 3 and 5. And actually between 6 and 7, it also has a, so slowing down, and here I'm going to add it to, and between 6 and 7, right? Because v of t is positive and a of t is negative. So the other one is going to be between 3 and 5. So particle A is slowing down, right? Same thing, on 3 to 5 because v of t is less than 0 and a of t is greater than 0. And then lastly, next two parts says over which time will this particle be increasing, right? And they're giving us a different function right here. So for this, we want to use a sign chart. So let's use a sign chart. So to do that, first we have to figure out when does this equal to 0. We just have to factor it. So that's going to be t minus 1, t minus 3. So therefore t equals 1 is equal to 0 and t equals 3 is equal to 0. So between 1 and 3, right? It's a parabola that opens up, and I'm pretty sure this is at 1 and then this is at 3. So this is going to be positive here, and then negative there, and then positive, positive, positive until we get to 9, right? Because we're going between 0 and 9. Remember that. And then this is b, and then the acceleration, first we have to figure out what's the derivative of this. So a of b of t is equal to 2t minus 4. All right. So here set this equal to 0 to figure out when it's changing. It's add 4 to both sides. 2t equals positive 4, so therefore t equals 2 on this one. So 2. So between 0 and 2, it's negative, and then between 2 and 9 is positive. All right. And then again here, using that information, if you guys notice, we can say that particle speed is increasing when both of them have the same sign, right? So both of them have the same sign here and here. So between 1 and 2, so particle speed is increasing between 1 and 2. Between 1, 2, and also between 3 and 9. 3 and 9, because both v and a, right, velocity, v of t and a of t have the same sign. All right. And then the last part, it says find the limit as t approaches 1. Be sure to again. So one of the things you guys want to do here, when it says, if you notice it, this is where you guys use L'Hopital's. So you want to make sure that you state this separately it's very important that you say this separately, right? So the limit as t approaches 1 of v of t is equal to 0. If I plug in 1, again, it's one of the zeros, so I know for sure it's going to be equal to 0. And the limit as t approaches 1 of v sub a of t, let's see where that goes, and that's from the graph. And if you notice again here, it approaches 0 as well. Since both of them approach 0, we're going to get an indeterminate form, right? We can say, therefore, L'Hopital applies. All right. And then you take the derivative. So the limit as t goes to 1 of the top part is just going to be 2t minus 4, right? We already know that. And then you want to find the slope of this one. So if you guys notice right there, we go down 4 and then 2 to the right. So therefore it's going to be negative 2. You plug in 1 here, you're going to get negative 2 over 2, negative 2, and that's just equal to positive 1. And that's pretty much our the limits using L'Hopital's rule.